Hello, today we will be learning how to identify linear and nonlinear functions. Go ahead and add linear versus nonlinear functions to your table of contents. You'll notice I'm on 67 to 68. We're still in Unit 4. Our objective today is to be able to identify linear and nonlinear functions. And then your essential question is, how do I determine the difference between linear and nonlinear functions? Feel free to pause the video to make sure you have everything written down. Let's begin with talking about the characteristics of linear functions. When linear functions are graphed, they will form a straight line. Okay, nonlinear functions are going to have some sort of curvy line. It needs to be written in the form of y equals mx plus b. We call that slope-intercept form. M represents the slope, and b represents the y-intercept. It's also going to have a constant rate of change. Rate of change is the same thing as slope. Okay, so what we have to do is determine if it's going to be nonlinear or linear. When I am looking at this, you have to ask yourself, is it in the form of y equals mx plus b? Well, sort of. We don't have exponents when it's in that form, so we already know it's going to be nonlinear, but let's take a look at this. We've already evaluated functions and created function tables, so I'm not going to show that again, but if I plug -2 in for x, I get -2 squared, which is 4, plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. And then 2 squared is 4, plus 1 is 5. When looking at this does not have a constant rate of change because we have a pattern, but it's not the same as what we're used to, where we're just adding 3, adding 2, subtracting 3, okay? Because this changes by 3. This changes by 1. Then we've got a change of 1 and a change of 3 again. Okay, so that means it's not a constant rate of change, so therefore it would also show that it is non-linear. If I were to graph this, so I'd do -2 to 5, -1 to 2, 0, 1, 1, 2, and 2, 5. You're going to see that it forms an upside down U, so that's not a straight line. Okay, so it's not a straight line. The table does not show a constant rate of change. Okay, and it is not in the form of y equals mx plus b. So this example would be nonlinear. Okay, so this is y equals 1/2 x. Is this linear or nonlinear? So let's go ahead and solve this. So 1/2 times -4 is -2. 1/2 times -2 is -1, 0. 1/2 times 2 is 1. And then 1/2 times 4 is 2. So when I look at this, I see a constant rate of change of adding 1 each time. So that's going to show that it's linear. And then if I were to graph it, so -4 to -2, -2, -1, 0, 0, 2, 1, and 4, 2. You would see that it forms a straight line making it a linear function. So we have a straight line and the table shows a constant rate of change. Okay, here we have y equals 12 over x, so we should recognize that it's not in the form of y equals mx plus b, but let's see what happens when we calculate this. So 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 6 is 2. So if we're looking at this, this is a change of 6, change of 2, change of 1, and a change of 1. So we can see that's not a constant rate of change. Those are changing at different rates. Let's see what it looks when I graph it. So 112 would be someplace up here. 2, 6, 3, 4, 4, 3, 6, 2. So we can see that it forms a line that looks something like this. So it's not a straight line, and it's not a constant rate of change. Okay, so let's see what we have here. Negative 4 times 2 is negative 8, plus 3 is negative 5. Negative 4 plus 3 is negative 1. 3 and 5. So we're adding 4. Let's see, negative 4 times 2 is negative 8, plus 3 is negative 5. Negative 4 plus 3 is negative 1, 3. Okay, I just wanted to make sure I did that correctly. And then we see we have a plus 2. Now, that might look like it's not a constant rate of change, but did we change by the same amount on the other side? So we added 2, but then we only added 1. So let's see what happens when we graph this one. So negative 4 to negative 5, negative 2 to negative 1, 0, 3, and 1, 5. So if we're looking at this, we'll notice that this did in fact create a straight line. So even though the table didn't quite show us that, the graph did. So this would be a linear function, okay, because it did form a straight line. Now, if we change this number here, that would have given us that constant rate of change. So it is important to check all of that. All right, negative 1 minus 5 is negative 6. 0 minus 5 is negative 5. 3 minus 5 is negative 2. And 6 minus 5 is 1. Okay, again, so it doesn't appear that we have a constant rate of change. But let's graph it. So I have negative 1, negative 6, 0, negative 5. 3, negative 2, and 6, 1. So again, it formed a straight line, so this would be a linear function. Okay, so just because if the chart doesn't show a constant rate of change, it is still important to graph it. All right, negative 6 times a third is negative 2, plus 1 is negative 1. 1/3 times -3 is -1 plus 1 is 0. 0 times 1/3 is 0 plus 1 is 1. And then 1/3 times 3 is 1 plus 1 is 2. So this one shows me a constant rate of change. So that means I definitely should have a straight line here. So -6, -1, -3, 0, 0, 1, and 3, 2. So we can see that formed a straight line. So this is linear. And then our last one here, maybe pause the video and see if you can do this last one. Hopefully at this time you've paused the video and you've worked this out. So this one is like a -1 times whatever x is. So -1 times -2 is a +2 plus 4 is 6. -1 times -1 is a +1 plus 4 is 5. 3 times -1 is 3 plus 4 is 1. -1 times 5 is -5. Plus 4 is -1. So it doesn't appear to be a linear function from the table, but let's graph it. So -2 to 6, -1 to 5, 3, 1, and then 5, -1. But it does form a straight line, so therefore it is linear. We should have also recognized that all of these were in the form of y equals mx plus b. Okay, so therefore they're also linear that way as well. Let's take a look at a word problem. The temperature at dawn was 52 degrees Fahrenheit and increased steadily 3 degrees every hour. Write an equation and graph the relationship below. Well, we haven't focused on writing equations yet, but in order to write them, we start with what it started with, and then every tells me I'm multiplying. So it's increasing, so that's plus. And then it would be 3. I'm just going to make it an H for hour. Okay, so we can rewrite it so it's in the form that we're used to. Okay, the commutative property says I can move that around. The other way we could have done this is just set up a table. So we have our hour, and then the degrees Fahrenheit. So when it started, it was at 52 degrees. And it's increasing every hour 3 degrees. So the next hour, I'm going to get 55. Hour 2, I'm going to get 58. Hour 3, I'm going to get 61, and this would continue. Okay, so that's how we would set that up. And we should recognize that this is a linear function based on the equation or based on our table, but let's also graph this. So I was starting at 52. That's where it starts. And then at 1 hour, I'm going to be at 55. 2, I'm going to be at 58. 3, I'm going to be at 61. And if I wanted to go further, and then we should see that this forms a linear line, a nice straight line. So this is a linear function. Hey, hopefully at this time you know how to pick them out. So now let's see what non-linear problems look like. So we'll notice we have these exponents here. So we should already recognize that it's going to be non-linear. Okay, so I'm going to start with 1. So 1 squared, to solve this, it would be 1 squared plus 1. 1 squared is 1, plus 1 is 2. So now I'm going to have 2 squared plus 1. So 2 squared plus 1 is 4, 5. Okay, then I'm going to have 3 squared plus 1. So 3 squared is 9. 9 plus 1 is 10. And then if we graph that, we would be at 1, 2, 2, 5. Okay, I can't get 10 on there, so I might go back and do 0. So 0 squared plus 1 is 1. And then what we probably see if we did negative 1 is it going the other way. So negative 1 squared plus 1 is 2. And you can see we get this U-shaped. So this would be non-linear. So let's take a look at another example. So I'm going to do 1 cubed plus 2. So it's going to be 1 plus 2 is 3. You'll notice I always use just small numbers, so it's a little easier. So 2 cubed is 8. 8 plus 2 is 10. Now we already know we can't get 10 on the board, so I might start going the other way. So let me try 0. So 0 cubed, 0 plus 2 is 2. And then if I did negative 1 cubed is negative 1, plus 2 is 1. So negative 1, we would get a positive 1. So now let's graph that. So negative 1 to 1, 0 to 2, 2, let's see if we can get 10 on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be just above. And then, oops, that should be over here. Sorry. And then 1, 3. Okay, so we see we get something that looks like that. And that's nonlinear. All right, so they already gave you the equation, and we see that it has an exponent in it, so we're not going to have a linear function. So here, I'm going to start with 0 this time. So 0 squared is 0. I'm going to go to 1. 1 squared is 1. I'm going to go to 2. 2 squared is 4. And then I'll do 3. So 3 squared is 9. All right, so let's graph this. So we have 0, 0, 1, 1, 2, 4, 3, 9. So if I did 4, I'd be at 16, and 5 would be at 25. And so here is, and you can see that that forms a non-linear line. All right, you try. Determine if the following are linear or non-linear. So go ahead and pause the video and see if you can determine which ones of these are linear and which ones are non-linear. Hopefully you've paused the video. Let's see how you did with that. So I added some additional notes over here to help you. But hopefully you'll notice my pink are the linear functions. So this was the only linear one, and then my orange are the non-linear. Okay, so the other 3 were non-linear. Okay, so try these ones. Tell me which ones are linear and non-linear. So go ahead and pause the video. Hopefully at this time you've paused the video and you've worked this out. So again, my pink ones are linear. So all the pink are linear. And then all the orange are non-linear. Okay, at this time you are ready to move on to your next assignment for today.